Let's suppose we have two kind of data, for example a bad sample of MPU 6050 and a good sample of MPU 6050. We sample that into separate CSV files, and normal sample, a bad sample, we simply read these two data set from the pandas library with the read CSV file. Then we put another column to them, which is a label column, and we put 1 to the normal data and bad one 0. So what we do is we are going to train a model of decision tree with the sklearn library. So we combine these data with a pd concatenate, so it will become a single data set. Then what we do, we need to split the data into features and the labels, excluding the timestamp. So we just leave the timestamp, and we put everything else as so we have a label and timestamps, we separate that. Then we just combine took a column of labels as a y and everything else in x. Then we simply do a train test split, and then we train a decision tree classifier with these two lines. We instantiate a simple decision tree classifier. Then we call a clf.fit function, and we give the x train and y train values, and then we clf.predict, and it will automatically predict the data. So how this works, it is a simple decision tree model which is then trained. And we could also took a column names from here, we created the column names, and then we can simply train this model again. So we'll see this classification report with a precision recall F1 score. And as you can see, the model is doing pretty good. Then we come down and we can simply plot this confusion matrix with the simple confusion matrix, and we put X test and Y test and Y prediction. And we can import this from the matrix confusion matrix, and we plot this with the matplotlib library. Then we can simply print the accuracy from, we can import that from sklearn library as well, from sklearn.matrix, and we print that accuracy, which is 0.99, which is pretty good for this data set. And we can then print a decision tree. So here you can see the decision tree is very easy to transfer onto the Arduino. The reason is that it could be translated into a simple C function which is based on if else statements. So this is how you can um, plot the decision tree. And here you can see that the features like ax should be less than this value, and all of that. These are the values. What is next? We can simply export this as a text, and this is how the tree will be plotted, printed into a text form. So if you grab all of this text and ask a chat gpt to create a c function, it will do that for you, and you can use that c function into your Arduino to test out. So for example, let me grab, I'm trying to grab this. Okay, so move to the chat gpt, and can you create a C function to be used in Arduino for this decision tree? And you put that, it will automatically create for you a C function, and you can use that, write some test cases for that, and you will get these test cases. And here let's grab a C compiler online and pick anyone you like and grab this one. Now copy this function and come to your C compiler and paste that function here and come down and let's grab this one and put that here as well. Let's see how it works and then simply hit run. So the test case 1 result 1, test case 2 result 1, test case 3 result 0 and 1 and 1. So this is most of the time in the Arduino we have simple feature set like these numbers. So we can this could be a MPU data set, just the way we grabbed some data from the MPU 6050 and we um, save that data into a CSV file. Then we train a decision tree with the Python, and then we print that decision tree and create a C function with the help of ChatGPT and use that function to predict either the data is 0 or 1. This could be a multi-class function, but in our case it is only a binary classifier which classify the input features into 0 or 1, which could be our prediction. So that's how a simple decision tree model could be translated to the Arduino and could be used on the embedded systems, which is pretty lightweight, faster to do if you have lesser data. You don't have to complicate things with the deep learning or anything else. As you can see, our model is doing pretty good with the 99% accuracy, and most of the time most of the models which we may need in the data in the Arduino, just like the weather data, the other things could be done in a simpler way if it could be fit with the decision tree. I'll try to replicate other machine learning models as well, so in the upcoming videos, so you may need to subscribe the channel so you don't miss out any upcoming video. That's all for today's video and see you in the next one. Thank you.